Hey, hello everyone and welcome in a new video. In this video we will just use what we explained in the previous video. So this is the persistent volume claim and the storage class. In this video we will just make two parts. The first part is dedicated to a deployment with a persistent volume and a persistent volume claim, and without storage class created by us, just to use the default storage class, so without to push a storage class manifest. And in the second part of this video, we will just create a storage class and use an NFS server just to simulate that we are an administrator inside our Kubernetes cluster, and we want to provide to our user, to our developers, some persistent volume through a storage class to provide the NFS storage through this storage class. So let's go for the first demo. Of course, I've created a new Kubernetes cluster with our K0s stack here. Like you see, we have two servers. The first one is K0s 10. K0s 10 is like a Kubernetes cluster, but it's just based on K0s, and the second server is just an NFS, our future NFS server, but for the second part of this video. So let's go for the first part. So let's go inside the K0s 10 virtual server, and of course we have only one server and nothing inside our cluster right now. If I check, yes, kubectl get pod, I can create a dedicated directory to make our test. We can say without storage class, or without default without custom storage class, because we will use the default storage class, and the default storage class is based on the name manual, and you don't need to create it. So let's go in without directory, and now we can deploy the first use case. So this is in this case we will use the host path mount. So we have already seen this use case. So the first thing that we need to do is, the first one is to create a persistent volume like an administrator, and in this persistent volume, take care, because we use the host path. That means that this storage and this directory is just fixed on this specific server. And if you have a real cluster, if your pod need to change to go to another worker, for example, you are sure to have an issue with that. So really take care when you use host path. We already saw that, because you need to use, for example, some stuff with affinity to be sure that this persistent volume is just used on the same server, and the deployment that we push need to use the same server forever. So let's go to create the persistent volume. So the name of the persistent volume is PV volume. We set just a label type local, for example. That is really useful, for example, for your developer to get more information and to filter your to allow to filter your persistent volume on some labels. And we fix the storage class name to manual. So this is a default storage class, but we will never create this storage class. And the capacity, we want to give 10 GB, for example, an access mode based on read-write ons, and after that the reclaim policy is to retain, to be sure to keep the data that we will store inside our host path, so on our host finally. And remember, we use here the type directory or create. That means that if the directory is not already created on the worker, it will be created. Okay, so we can push that directly like that. Okay, so now I can use kubectl get pv, and pv is not namespaced. That means you can only create one PV name, for example, PV volume for the entire cluster. So let's go. We have the PV here, 10 GB, read write ons. So this is the access mode, the retain policy available, so it's okay. We have the storage class set to manual, and it's okay to use it. So the second thing that we need to do is like a developer, we want to use this persistent volume, and to do that we need to set a new manifest based on the kind persistent volume claim, and this is this persistent volume claim which will be mounted inside the deployment that we will use. So we set a kind persistent volume claim, we set the name of this persistent volume claim, and especially for persistent volume claim, this is a namespaced resource. That means that you can set for a specific namespace. Here by default that will be in the namespace named default, and this PVC dash volume can be created in each namespace that you have inside your cluster. And to match our persistent volume that we already deployed, we set the storage class name to manual. The access mode we need, of course, to match the read write ons like on the persistent volume. And we want to request from this persistent volume only 1 GB like that. And okay, now I can copy and paste it inside our terminal like that again. And if I check again kubectl get PVC, now we have the PVC. This PVC status is bound on the persistent volume named PV volume, provide for 10 GB, and we have the access mode read write ons, the manual storage class, and yes, and that's it. And we can check the persistent volume, and now you can see just before the claim was not bound, so the status was not bound, and you can see here we have now in persistent volume resource we have the status bound, and in the claim before it was just empty, but now it's a default for where in which namespace we use it, and we use it in the default namespace with the PVC named PVC-volume, so it's okay with the storage class manual. Okay, now we can use it, and to use it we need, of course, to create a pod, and to create this pod we will use a Postgres pod, and to do that we use a deployment. We will see later what and how to create a stateful set, but for our deployment we have the name Postgres, only one replica, the selector for our deployment based on the label app and the name Postgres, and the templater about the pod that we want to create. Of course, we need to create the label app and set it to Postgres, like we have a match label. And after that, some specifications about our only one container in our case. Name of this container is Postgres in the version 16. And after that, we want to set, for example, the Postgres user by default admin, and the password about this Postgres will be password. Of course, you need to change it if you want. And the default database, because by default we can create a database when we run the container, and we want to create directly a database named testdb. We want to set the container port to 5432, and after that, of course, we need to mount some stuff. And to mount some stuff, we need first, like, and with the same indentation about containers, we have the same indentation for volumes to declare and to set our volume. So we want to have only one volume, like Postgres -data, and we want to use not a host path, not a config map or stuff that we have already seen, but a persistent volume claim. And in this case, we just need to set a claim name based on our persistent volume claim name, and this is the PVC-volume. So if I push that, like that, of course, now we have a pod, Postgres pod, so we need to wait that the Postgres image will be pulled, and after that we can expose and create a dedicated service for our Postgres pod. And for example here, the port 5432 on the target port, so this is the port about our pod on 5432. So I can check it's okay, and to check that and to check if the label is good and our container is just and the pod up and running, we can check kubectl get endpoint, and we can check okay, we have a match because we have some endpoints, and only one endpoint in our case, on the service Postgres. Now I can use it. That means that we can use a kubectl run and run a pod named client, and the image inside the pod is just the Postgres 13, but we can use 16 too, and --bash like that. Okay, and I can just test to create a table just inside our default database. So that means that we need to use psql -h and the DNS about our service provided by our service, so Postgres or Postgres.default, because the namespace is default, can be used, and -u for the user admin and -d for the database. So let's go, and now I can just enter my password. So this is password, and I can create a new table. So this is a Xavkey table like that. Okay, and it's okay. So I can insert into the Xavkey table for some value inside it, for example like that. So values like that, and the value 2 and the value so the value 2 and the value 3, for example. I can now select store from Xavkey to check the content about this table, and we have 3 lines. And that means if I just exit from the client pod, and if I destroy, I can just kubectl scale to 0 our deployment, Postgres deployment, -replicas, and set to 0. That means, of course, our pod is over. Okay, and I can now, because I have kept my deployment, I can now scale it to replicas 1. Okay, I can check. Now we have a new pod, and normally, if our data are persisted, we can run again our client like that. Run the psql. So this is not the psql. The psql -h Postgres and the user -u admin and the database test db, the password again, and if I check inside our table named XAF key normally. We have and we keep our content, so our data are persisted, so it's cool. So this is the first part of the demo, and it works. We can just destroy so kubectl delete our deployment, name Postgres. I can also kubectl delete our PVC. So the PVC is named PVC volume dash volume like that, and we can destroy the PV2. Okay, and if we check, because we retain the data, if we check the slash data, we keep the content about the Postgres. So this is the PG data content. So we have all files about our PG instance, and we can remove it because we don't want to reuse it for the second part of our video. So let's go for the second part. So we can create a new mkdir, so storage class NFS like that, for example, and storage class NFS. Okay, now we can test to create an NFS server. So we need to go on our dedicated server like that, I think. Okay, I am on it. I need to set and to install an NFS server, so it's really quick to do that. So cat NFS, you can reuse the same things that you have, but never set it to 777, but it's just for the demo part. I just install a NFS kernel server package, create a dedicated storage directory, and set the /etc export to set that we want to use /srv/data. So this is our directory. Restart the NFS server and rpc bind. Check the export ifs and check that we can use the things. So we can do it like that. I don't remember if we use a Postgres too. Yeah. So we don't need to do that, but just we can do that. So let's go. Yes, let's go like that, I think. That takes few seconds, and now normally we will have sorry, where I did some stuff. So normally it's okay, because if I just make export fs -a export, we can export I can check again. Export fs. No need to use the sudo. Maybe I just sorry. And export fs again. It's okay. So we have it. We have the here /srv data like that. We can check the permission on it. So LA, for example, and it's okay on it. But never never set this kind of permission on whatever. But never, never do that. Okay, so now we can use it, and to use it, what we can do, we can create first a persistent volume as for example an administrator. Okay, I can create it. So I need to go on our Kubernetes cluster. So for example on a master, or just where you can use a kubectl to pass through the API server. And now we want to set a new persistent volume named PV-NFS like that. We set our custom storage class name named NFS storage. So I need before to create the storage class like that. So no need to set many things, but just the name of the storage class, NFS storage. The provisioner, we said that we don't want to use a dynamic provisioner or stuff like that. It's just an NFS and we handle the entire process. And we want to mount only the volume when we need to use the volume. So when we have our first consumer, our first pod. So let's go. And now we have a storage class or SC. So this is just an alias, but you can set storage class if you want. This is exactly the same thing like as usual. If you check the content, we have the storage class, no provisioner. The reclaim policy here is not delete because the default reclaim policy is delete. But we can, if really you need to make a production ready stuff, it's better to begin with retain to be sure to keep the content about the data. And we don't allow volume expansion with dynamic stuff. So this is the default things, but you need to adapt it to your provisioner if you have a dynamic provisioner or if you have a cloud provider. And in the next video, we will discover a dynamic provisioner for NFS. So you need to take care today how we handle that manually, but we will use it dynamically in the next video. So let's go to create our persistent volume. So the name of the persistent volume, and we set here our new storage class, our custom storage class. We want to provide the capacity to provision 10 GB. The access mode is set to read-write ons. The persistent volume reclaim policy is to retain, but normally we need to have the same thing that we have inside the storage class, and we want to set not host path like in the previous demo, but NFS, and where we can find our NFS server. I need to check before because I think the IP is wrong. Yes, the IP is wrong, so I need to change it. So this is the 16 here. Yes, and that's it, I think. And yes, and our directory on the NFS server. So it's okay like that, I think, and you can check with kubectl get pv. So it seems to be good, yeah. And now we can create, like previously, create our PVC. So this is like we have an agnostic part due to the storage class, and we set a persistent volume, and we don't need to take care about what is the storage and the storage engine that our administrator provide. So we want to create a new PVC, but with the same name that we used previously, okay, and we will create the same things. And we can check again the kubectl get PVC, and we are pending because this is due to if you check kubectl describe PVC like that, you can see we are just waiting our first consumer. So this is our first pod, and this is due to our policy, and we want only to mount this volume if we really need to use it. So now we can reuse exactly the same deployment with the same pod to use a claim name PVC Postgres, exactly the same thing that we used previously. So let's go. And now, if I check again, we have a container creating, but I can check again also the PVC. And now we are not in pending status, but we are in bound because we have our first consumer. So it's okay. If I check, of course, the PV, it's okay. The mapping is done because we have default /PVC Postgres. That means that now we need just to download, to pull the Postgres image. So normally that takes few seconds. I can check, describe pods, and the pod here. Oh, we have an yes, we have an issue. Yeah, because we haven't the NFS client on our server, so we need to install it. Maybe just sudo apt install NFS common, I think. Yes, it's NFS common. I can destroy again, I think destroy the pod, or just maybe automatically. Yes, it's running. Now it's good. It's dynamic, cool. And we can describe again the pod. You can see here the fade due to the fact that we haven't the NFS client installed on our worker. So now it's okay. And now we can deploy again our kubectl run client. Okay. And psql dash. So I can check before if we have a service, but normally if we reuse exactly the same thing that we have previously, the service and the endpoint is good. Yeah, but we just change the pod. And we can reuse the kubectl client, psql -h, the same DNS, but we can use, for example, the default or default.svc.cluster.local. We have already seen that in a previous video dedicated to service, because service provides an entire DNS, and we will see later how it works behind the hood. And now -u uppercase, and this is admin, and the -d and test db, like that, and the password about our user. So it's okay. I can create because we lost and we drop the data. We want to create a table name, for example, xavkey, and with just id hint, like that. And it's okay. I can just now insert into xavkey some data. So we need to set a value, but we can use the uppercase to be strict. And now in the value we want to have, for example, here 11 to change, and 12 and 13, for example. And now select store from xavkey. It's okay, we have some data, and we can do the same thing like we do in the previous demo. So we can just kubectl scale, or we can directly delete kubectl delete deploy and our Postgres deployment. So we lost everything, but not the data, because if you check on the NFS server here, if I just use ls/srv/data, we have all the pg data content inside it. So normally now I can redeploy again the deployment, so I can reuse it. And yes, we can go with the entire things, and we can because we retain the yes, we retain, so we can use kubectl get pvc, like that, and we can delete the pvc like that, and the pvc named Postgres, and we can drop the pv, because normally we are in the retain mode. So pv Postgres, I don't remember. No, kubectl get pv. What's the name? Pv NFS here. Pv NFS. So delete. Okay, I can delete because we are in retain mode. And if I check again here, we keep the entire content about our pg data. So normally I can recreate all objects like that. So I can use, for example, the persistent volume first. Okay, I can push the persistent volume claim, of course, and after that we can push, of course, our Postgres deployment, like that. Okay, let's go. And kubectl get pod, so take a few seconds, but normally it's quick because we already pull the image, so need to wait a little bit. I can describe again, describe so kubectl get pod. Oh, we have something. Kubectl describe pod. Maybe I missed something. No. Successful assigned to, so normally it's good. No, there is something missing. What? So I can check kubectl get pv. So we have the pv used by the pvc, so it's okay. What I miss? And we have the pod here. Kubectl get pod. What I miss inside it? Because we keep the storage class, I think, yes. So it's okay. Wait for the first consumer, yes. I missed something. I don't know what. Because normally it works. Yes, we keep the entire data. What can I do? I can recreate the storage class too, to be sure. Kubectl get events can be really useful to troubleshoot. So we have the wait for first consumer, waiting. Oh, this is the waiting for first consumer to be created before binding. Okay, maybe it's just the order of the things. Scale replica, so that was just before. Scale up replica. So what we can do, we can just kubectl scale deployment Postgres, and we can scale it replicas to 0. Okay, kubectl get pod, of course normally it's good. I can have a look on PVC and on PV. So yes, okay, because normally so I can set replica to 1, PVC, okay, and kubectl get pod. I missed something. I don't know what. I can drop again because I don't see what we have. Really weird. I can, okay. Delete deploy. So this is a demo effect. Delete the PVC. So PV, so PV, comma PVC dash dash whole, like that, and we can delete the storage class too. Delete the storage class dash dash whole, like that, and with that we delete all the things. And now we can recreate the storage class to be sure. But normally we don't need to do that because we keep exactly the same thing. So we can set it, set the persistent volume. Ah yes, I know, because the IP is wrong. Okay, sorry, my bad. I don't change the IP. Okay, so really logic. The IP was 46 or I don't remember. IP here. Yes, this is 16 here. Okay, and yes, now we can create the PVC. Sorry for this issue, and we can recreate the deployment now. Okay, like that. Okay, and kubectl get pod. Normally it's quick. Yes, it's better. I can run the client again, and after that I can use a psql -h postgres like that -u admin -d test db like that, and it's okay. Okay, so now I can check if I keep our data. So from Xavkey table, and we keep our data, so it's cool. That's it for today. Thank you for following this video. Don't hesitate to subscribe to the channel and to go on the homepage about the channel to discover all videos that we have on the channel, and like and comment this video. See you in the next one for the dynamic provisioner. Bye bye.